Hey Dweebus, what are you doing here?
Hey Pranav, you want to take my lunch money again?
No, I want something more rare. Your rare pseudo-wudo card.
Please, anything but that. It's the last thing I have of my grandma.
I'm gonna get it no matter what. 5/4 if necessary. William, come
Pranav,
out
we
here.
can talk about this. We don't have to.
Fine.
I'm sorry, Grandma.
Take that junk. Haha. Say thanks to your grandma for me, Dweebus.
She says you're welcome.
What's happening?
Tectonics, stop!
Don't mess around on my tectonic plates.
How would you describe the Earth? Continents, obviously, the oceans, rivers, lakes, mountains, forests, deserts, and add a bunch of other stuff on and you've described pretty much the entire surface of the Earth. But you're leaving out one planet-sized factor, which is everything that's underneath. Now, imagine that there's a leaf in that pond. That leaf is floating on everything else that's underneath it. And that's kind of what the crust is, the surface of the Earth, to what's underneath, the mantle, the lower upper mantle, the core, and the asthenosphere. This whole theory of continental drift, which is the idea that the continents are moving away from each other, was proposed by Alfred Wegener in 1912. He thought that the continents of South America and Africa looked like they used to fit together, and you can kind of see that if you look at a geode like this. Sure, there are some missing cracks here and there, but ultimately, if you remove them and you drift them far apart, the rocks underneath stay the same. And not just the rocks, but also fossils. Fossils were found on both continents that were extremely similar to each other, so either they co-evolved and evolved in something extremely similar, or simply that land used to once be together. Now, when Alfred proposed this, he was laughed out of every room that he proposed it in, because he just didn't have an idea to prove why it happened. And that's what we'll be teaching you here today.
Hello! Today we're explaining continental drift, or the hypothesis that continents have moved apart from each other over time. This occurs because convection currents from inside the Earth's mantle cause different tectonic plates to shift. We're going to be showing this using water, which represents the mantle, which is the inner and outer layer. We're going to have oil, which represents the asthenosphere, and then over top we're going to have a piece of paper floating, which will represent our tectonic plates. So the way that continental drift occurs is that radiation and heat from the Earth's core move throughout the mantle into the asthenosphere, causing motion. And this motion causes different tectonic plates to move around, and such the tectonic plates drift.
Hello, Pranav!
Hello, it's been a while.
It has, it's been a bit, yeah.
Yes, so you wanted to talk about
Convection
convection
currents.
currents. That's interesting.
So yeah, in this visual, you can see that convection currents are caused by both the heat from the Earth's core from all the hot iron and pressurized stuff, and also radioactive decay from elements like uranium and thorium, so they produce heat, and then they cause the bottom layer of the mantle to heat up, and this causes it to want to rise. And as it rises, it displaces the colder, more dense lava or magma, and then it pushes it down, and this creates a cycle. And these are known as convection currents, and this is what's believed to be the main factor for continental drift. And yeah, that's what continental drift is all about.
A place to find diverging plate boundaries in our natural world is actually in our sea floor. These mid-ocean ridges, which you can find if you look on a map and you look at the topography in the ocean, magma flows up from under them and they kind of just spread. They increase the sea floor. That's why it's called sea floor spreading. When this magma comes up from under, it's known in the form of a plume, which my friend William will be explaining.
So put simply, a plume is just hot liquid rock from the asthenosphere that gets pushed up. When a plume reaches the Earth's surface, it results in volcanic activity.
So do you have any demonstrations to show us?
Yes. Okay, so imagine that flower was the plume. Once it was in your mouth, it kept building up pressure until it exploded, representing how a plume works. And when plumes occur far away from plate boundaries, these are called hot spots. An example of this is Hawaii. You can see how the hot spot never moves, but the plate itself is moving away.
For this next one, we gotta go to Africa. Now, a place where you can also find diverging plate boundaries, and not just in the ocean, is actually in Africa. Now, this is because there are two continental plates that make up this continent, the Nubian and the Somali plate, right? And now the Somali plate is heading eastwards, and the Nubian plate is heading not eastwards. This is currently called a continental rift because it's the gap between the two continental plates. Now, as this gap expands, as the Somali plate heads eastward, there will be magma that rises from up and underneath and creates a new sea floor, which will lead to it becoming an oceanic spreading ridge because the ocean will begin to spread. Unfortunately, it'll be millions of years before an actual ocean forms. We can already see some activities happening because there's a whole lot of volcanic activity that happens along this area, and there are rifts that pop up, rift valleys they call them. And yeah, it's just a whole lot of fun. Kabir, how are you?
Hello, Seth. I'm pretty good. How are you? It's been a
I'm doing.
while.
It has been quite a while. It has been. So I was hoping that you could talk to me today about convergence, and different types of convergences.
Okay, well, there are two types of tectonic plates. Why don't I show you here? There are oceanic plates and continental plates. A continental plate meets a continental plate. It does a little something like this. Wow, that's called
Wow,
subduction.
that is
And
awesome.
normally when this occurs, what happens is there is now more stuff in the same amount of space, which causes increase in pressure. And this increase in pressure causes lava to leak out. And as it leaks out, it comes up to the top. When it cools, bam, suddenly there's a new mountain formed there. When ocean plates meet ocean plates, the same thing occurs. It's just both of them are slightly heavier because there's more water within the actual rock plate that meets each other. Like the San Andreas Fault near California, that's a big one because it's doomed to have a big earthquake soon. It's gonna look something like this, and it's gonna create some new landscape, and it's gonna destroy a lot of things.
Sorry, you said San Andreas Fault. Can you just tell me what a fault is?
A fault is where two different tectonic plates meet.
Now, continental tectonic plates are not as dense as oceanic tectonic plates, which is why we're using this dry sponge for the continental one and this wet sponge for the oceanic one. When these two plates are forced to meet, the dense one being heavier, of course they'll have some resistance, but eventually the continental one, being not as dense, will go over, and the heavier one, the oceanic one, will be forced to subduct underneath it.
A transformed fault is it's how tectonic plates meet up against each other, and maybe different regions of the tectonic plate don't move the same, and this causes breaks within the tectonic plate. And this change in rates causes it to move slightly differently, and then it builds up pressure until eventually, boom, there's a big shift, and this causes an earthquake or a tsunami or volcanic activity.
So for example, this lower piece doesn't move as quickly as the top one, and because of that, it builds up pressure, and then once it releases, earthquake.
Exactly.
So a fault line is just where this occurs. This like area where it gets
The
broken.
collision between plates.
So kiddo, your mom and I are gonna be taking a break for a little bit.
What? Was it my fault?
No, it wasn't your fault, son. There's nothing you could do. I'm sorry that you got caught up in all this.
But how am I gonna be on my own? I can't do this on my own. What do I do?
You know, kiddo, it won't be all that different from what we have now. I mean, you'd get 2 new continents, a new sea floor. Don't tell your mother I said this, but it's all because of her damn plume. That friend of hers that just keeps telling her that she should be moving away. She's moving away from me. I'm never gonna see her again. Not for another couple million years, of course.
There's no fault, is there? Whose fault is it? There's no fault between you two anymore. You're not sharing one. I'm going to melt under all this pressure. It all amounts to what? The joke is that they're continents.